On your mark, get set, go. Okay. Vectors dot product. If U is equal to the component A1, B1, and V is equal to the component A2, B2, then U times V is equal to A1, A2 plus B1 times B2. That's the dot product. That's how you multiply components of vectors. It's hard to describe really why you would use the dot product until we see an application for it. And really the application comes when we want to try to find the angle between two vectors. And the angle between two vectors can be defined as follows. We'd have cosine of theta is equal to U times V, or their dot product, divided by the magnitude of vector U times the magnitude of vector V. So again, are you getting a sheet of notes for your test? No, you have to make them all. You have to make your own. So you're going to want to highlight this stuff and write it down. Okay, that's going to be up to you. Okay. You can put examples, put formulas. No. Otherwise, I would just give you your whole sheet of, packet of notes for the entire test and your study guide and your book, and that would be called an open note test. This is like a test with formulas. You guys should say, no, Mr. Gens, please make the test more difficult so you can extend our learning. Oh, all right. Okay, here we go. So let's understand the framework of this problem. It says find the product of the vectors and the angle between them. So I have -1, 2, and I have 2, 3. So you don't have to do this every time. I'm just going to do it the first time. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. If I plot -1, 2, and then plot 2, 3, that's vector U, and that's vector V. So the dot product is going to be, the product of these two vectors, which is going to come out to a single number. And then what I want to find after that is I want to find the angle between them, theta. And, we could show you, we could prove both formulas to show you why it works out, but we're not going to take the time to do it. If you want to, you can go ahead and look in your book. You might have an example. But we're just going to carry out the basic operation. And in order to do, so it says find the product of the vectors and find the angle between them. So I'm going to look for theta. Yeah. Well, this works just the same. You could use your finger if you want. Just this has got a finer point to it. So okay. So we've got U times V is equal to, all I do is I multiply the x values. So I get -1 times 2, and then I add the product of the y values. 2 times 3. So I have -2 plus 6 is 4. Easy peasy? Okay, if we want to be able to find the angle formed between those two vectors, that's pretty interesting. And all we do is we just set up the formula that we were given from above. So we're going to look at this formula here, and we're going to set it up. So I've got cosine of theta is equal to, we already know U times V, right? It's 4. Divided by the magnitude of U times the magnitude of V. Do you remember how to find the magnitude of a vector? Very good. Miss Barber has it. She sees exactly what you're supposed to do. Remember that if you have a vector like this, it has a vertical component, it has a horizontal component, so we call it vector AB, in that form. The way that we found the magnitude of that vector is we did magnitude of V is equal to the square root of A squared plus B squared, which is simply just the Pythagorean theorem. Remember that? So we need to do that for both U, and we need to do it for V, and multiply them together. So let's do that. Okay, so the magnitude of U, I have the square root of 1 squared Negative 1 squared plus 2 squared. It's going to be square root of. Very good. Square root of 5. So the magnitude of that vector is square root of 5. What's the magnitude of 2, 3? Square root of 13. So I get cosine of theta is equal to 4 over the square root of 65. And I don't have to, rationalize the denominator because I'm just going to use it to find an angle. It's not going to be expressed in that form in its final result. So I go to mode, make sure I'm working in degrees, and then cosine of theta, or cosine inverse, excuse me, of 4 divided by parentheses square root of 65. And I get 60.26. Any questions how I did that? No? No questions? So this angle right here, theta, right there is 60.26 degrees. And, that's pretty useful to find. It wasn't very difficult for us to do, was it? It's pretty straightforward. What I would like you guys to do is I'd like you to do the next example on your own. Now, don't be confused when it says that A is equal to I minus J. That could just be rewritten as what? 1, negative 1, and B as would be 3, 4. So, that's just, vectors in IJ form, so that's it. Just write it like that. Okay. What's that? Yeah, A and B are the same as U and V, okay? Those are just the names of the vectors. Go ahead. I'll pause this. Okay, so let's see what you have. What'd you get for the product? Anybody? Negative 1? So then you had the cosine of theta is equal to negative 1 divided by square root of 2 times the square root of, or square root 2 times 5, excuse me. Is it not negative 1? So, okay, just watch. What's 1 times 3? 3 plus. What's negative 1 times 4? It's negative 1. So how did you guys get 11? No. So A sub 1 would refer to the first values. B sub 1 and B sub 2 would refer to the second values. So A is the first values. So you did 1 times negative 1, then you did 3 times 4. No, you do 1 times 3 and negative 1 times 4. You multiply the x values and multiply the y values and add them together. Does that clarify the question? Alex? Tara? It was like everybody in this vicinity right here. Weird. All right. Okay. Cosine of theta is equal to negative 1 over square root of 2 times 5. So when you inverse that, you get a negative value for cosine. So that means that the angle is, cosine is negative in the second and third. So it's in the second quadrant. So therefore, it's obtuse. What'd you get, Miss Bailey Barber? Good. Any other questions? Okay. All we're going to do is orthogonal vectors, and then when you're done, you're going to have work time. Orthogonal vectors, perpendicular. So, let's see here. See who's really smart. We should be able to figure this out. If the vectors are perpendicular, what angle do they make? 90 degrees. What's the cosine of 90 degrees? Somebody please help them. It's 0! So, if you're going to inverse the cosine of 0 to get 90, that means that, as we solve for the equation, you got to get 0. So if u times v is equal to 0, then you have perpendicular or orthogonal vectors. How do you like that? So determine whether the following vectors are orthogonal. We'll simply multiply them. So you have 2 times negative 1 plus 1 times 2. So negative 2 plus 2 is 0. Are they orthogonal? Yes. Your book actually says test for perpendicularity. I know, I said that second hour, and Larry started laughing. He said it sounded like I said perpendicularity. Perpendicularity. Or perpendicularity. There we go. Okay. Difficult word to say. Okay, how about the next one? Are you sure? 5 times negative 6 plus negative 3 times 10. That'll be negative 30 plus negative 30. Well, that's negative 60. So, no, those are not orthogonal. That's all you do. That's all I have for you today. So you have the rest of the time to work. You have all day tomorrow to work. On Thursday, we cover the remaining material. Friday and Monday next week, you have time to work on your study guide and homework. How's that? Say, Mr. Gentz, you should be Teacher of the Year. Why did you not vote for me? Okay. There you go. 7.8, page 608, numbers 1 through 6 and 9 through 12. That is your assignment. That's it. Precalculus is currently an extremely popular subject. Books are leaving my room. I do not keep track of them. I have no idea where they are. They're probably in people's bags. They're probably in their... I saw a lot of pictures over prom with math books, so who knows where they are. I mean, they could be at restaurants. They could be... You found your brother's book? That'll be nice to return that. Casey Gilbertson just found her book in 4 different pieces. I have a book here that's still in decent condition as well. If you wanted to, Megan Boss would like one. You should share or use that one. Actually, I've got a really good idea. What if you use the book that I gave to you? There you go, folks.